Okay, once again back. Hello, my dear kids and standard students. Okay, another interesting class of physics. How is it? Physics is easy. I hope physics was easy for you, isn't it? Next chapter is more easier than this. Okay? It's I know it is a bit difficult for you. Okay, you are only 13, 14 years old. At your maturity, you don't have that much mental maturity to understand a lot of things like this. But just put that concept inside your mind. Okay, put that concept. Okay, anyway, last day we were discussing about our first chapter of motion. Actually, it is the introduction for you, introduction of physics into your life. So, 9th standard is the time when you are going to study science in detail. Basically, during your 6th standard, 7th standard, and 8th standard, you have studied a lot basics. Mostly regarding biology, you have studied a lot of things. Chemistry, some of the things you studied, but the real starting of physics, you studied physics also. A part was physics, but those was actually practically we cannot use for higher studies. Now we are going to study detailed physics. In 9th standard it starts. 10th standard, actually regarding the syllabus of 9th and 10th, this 9th is more difficult than 10th. Not difficult. Actually it is classical mechanics you are studying in 9th standard. In 10th standard you are not studying classical mechanics. It is about electricity, magnetism and all. That is not that much difficult. Not difficult. Difficulty level is same. But the interest, the students they don't have any interest regarding this classical mechanics. This mechanics and all. The other parts is thermodynamics, which we study about heat and all. Optics we are studying about light. That's all things we will study next year. Magnetism is there. We study about magnets and all. But here we want to study this chapter. This is the base one. Last class also I told. This class also I am telling. This is the main base regarding the entire thing you will study in physics. Okay? Without this motion, scalar, vector quantities, displacement, distance, there is no physics. There is no classical physics. Understood? For higher secondary, that is PUC first year, second year, and if you are going for any science field, engineering and all, even for the medical, 25% mark comes from physics. So this is very important. This is the base concept of the physics, and if you understand this, your next chapter will be easy. And if you understand this, the future chapters will also be very easy. And if you don't understand this means, who knows what. Anyway, any doubt means you can openly ask it. Okay, any doubt. Actually, these doubts must be cleared directly, but this situation, this traditional class system is very difficult. So, what is happening? So, regarding this, we cannot show live examples. That's the main problem of classical mechanics. This mechanics has some limitations, but you must think it in mind, just like philosophical classes. Not like a science class. In science class, the teachers will show you live experiments and all. But here, how I can show? It's very difficult to go to market and go to there and east, west, north, south. Very difficult. But if we are together, we will sort out some other ways to find all those things. But just remember all those names and with one example. That's the main concept you must have in your mind. So you studied about scalar and vector quantities. Actually, it is not a part of the chapter, but it's a very important part of physics. Okay, scalar means only magnitude is there. We can measure it. That's it. For example, length. We can measure the length, but there is no magnitude. See, we can measure the length 10 centimeters. No magnitude. Magnitude is there. No direction. This direction 10 centimeter. This direction centimeter. Here also 10. Here also 10. Here also 10. Right or not? But vector quantities means they have both directions and magnitude. For example, force. I am telling about quantities. Length is a quantity. What all things we can measure is a physical quantity. For example, heat, physical quantity. What about light? It is also a physical quantity. Tell me, light is scalar or vector? Because light is light is not a physical quantity. We cannot measure light. How we can measure light? Can you measure light? This much long, this much big, No, we can measure the speed of light. We can measure the speed of light, we can measure the brightness of light, we can measure the wavelength of light, frequency of light, but we cannot measure light itself. Understand? So it is not a physical quantity. Leave it. So, vector scalar. I think you understand that. Magnitude. Here, direction also involves. Here, next one is distance and displacement is the starting of this chapter. Distance means distance. The length between two places. That is distance. Anyhow, if we are going like this, if we are going circle, whatever direction we will go, the length between two places is called as distance. But displacement is the closest distance between two places. Let's say, for example, see, here is one point, here is one point. Like this I am going. Understand? This will be the length. Here is 1 meter, here is 1 meter. Can you see that? No problem. This is A, this is B. Here distance is here 1 meter plus 1 meter, 2 meter. But displacement is this one. The closest distance. Okay. One more example we will see. So this is the starting point. Okay. And this boy is, and this is a ground. This is a big ground. Understand? So this is a big ground. And one entire round is 200 meter. This is the starting point. A boy named Usain Bolt. He's Usain Bolt. See, he has some small hair in his head. What is he doing? He is running this entire ground. So here is the starting point. So actually this boy rotated this entire ground for 2 times. Okay, 2 times he rotated. Okay, find the displacement and distance first. How many of you got distance as 400 meters? Don't need to find it in paper at all. Just in mind, just find it out. How many of you got this in mind? 400. So it is the total distance covered. One round, 200 meter plus second round also 200 meter. And what is the displacement here? Displacement. How many of you got 0? Why? Because he covered this 2 times. But where is the starting point? Here. Where is the ending point? Here itself. So what is the equation for displacement? Final point minus ending point, final point. The total distance traveled is 0. No, so the total measure is 0. And ending point also, initial point also same. 0. 0 minus 0 will give 0. So displacement can be 0. Keep that in mind. Understand? Displacement can be 0. But distance cannot be 0. Understand? Displacement can be 0 or negative. Understood? Or negative. I will see that equation. But distance will always be positive. Understand? It cannot be 0. How you can say the distance is 0? Can we measure 0 distance? No. 0 distance means nothing. If something is moving, it already covered some distance. Understood? This distance and displacement we are calculating in the case of motion. Understand? Motion. 0 kilometer length we can say that. But regarding motion, if somebody is moved, so this pen is moved from this part to this part. And then this part again to this part. At that time displacement is 0. But distance is the length from here to here, here to here. So whenever a body moves, there is a distance. So distance cannot be 0 or negative. It cannot be 0 or cannot be negative. Okay, distance is always positive and it won't be 0. But displacement can be negative also. Let's see. This is a line. Okay. This is a line. We have here 0, here 1, here 2, here 3. Here also minus 1, minus 2 and minus 3. So what is happening? Our boy is starting from this point A. At first, what he did, he traveled and he reached this point. P, boom, boom. Isn't it? 3. Here is B. Then again he went back here and stopped at 0. Okay? Now what is the distance? What is the displacement? Very easy. Distance is 3 plus 3, 6. Displacement is initial position minus final position. Okay? Initial distance minus final here 3 minus 3, 0. Am I right or not? Not 3 minus 3 is starting from 0. So 0 minus 0 will give 0. So here displacement is 0 and distance is 6. But he didn't stop here. He moved here and he reached here. Understood? So what is the total displacement? Tell me. So displacement in this case S is equal to 2. It is positive or it is negative? Confusion. Of course it is a confusion. So let's do it with the equation. Initial position is 0. Final position is minus 2. 0 minus 2 will give us what? Minus 2. Understood? So displacement can be negative also. For example, if we are doing in the case of force, this cap of the pen is the tip. Okay, we are applying 10 Newton force from this direction and 20 Newton force from this direction. Okay, so what will be the total force applied? What is the total force applied? 10 from here, 10 from here, but in opposite direction. In opposite direction, is force is applying means we need to subtract. So 10 minus 20 will give what? Minus 10. That means displacement can be negative and distance cannot be negative. Like a chart, I will give the properties of all those things. So hope you understand what is this displacement. Okay. Okay, the next one we can go with something else, which is called as what? Wait 1 second. Okay, we will start to the next part, something called as speed. Speed, and one more thing is there. I think this is new for you. Speed and velocity. Okay, speed and velocity. So what are these things? What is speed? What is velocity? If you are going through a highway, you can see the car is moving with high speed. You are, oh, it is going by high speed. Sometimes you will say it is going very slow. Speed is very less. So what is speed? Or how can we calculate this speed? We know that this cheetah will run with the speed of 121 kilometers per hour. Human beings like maximum 30-40 kilometers per hour. But how we can calculate this speed? Simply if you sit in a car and if you look to that meter, one meter is there where the speed is measured. If you look at me, it will say that 0 kilometer per hour, 2 kilometer per hour, 3 kilometer per hour, 10 kilometer per hour, 50 kilometer per hour, 100 kilometer per hour. Means what? Kilometer is what? Length or the distance. Okay, distance traveled by that car. Hour is what? Time. That means what is speed? The distance traveled by something, what all things? Distance traveled by a matter. Okay? Distance traveled by a thing in a particular time. So, distance traveled. Not this one. Wait 1 second. I hope this is a class.